In this lesson, we will be learning about conjugate acid-base pairs and how to write chemical equations involving acids and bases. What we have here is HCO3-. This substance can be both an acid and a base. When it can do that, it is called amphoteric. The book uses amphiprotic, which focuses more on the protons. So for this class, we will use these two terms interchangeably. So first, let's look at HCO3- and look at the structure. So really, this came from carbonic acid, which is H2CO3. As you can see, this can potentially give two H's. The structure looks like this, where here's the C, the three O's, and here's the H here and another H here. Because one of the H's has already left, it left an electron behind, which gives it a -1 charge. Please pay attention to the charge. So this HCO3- is called the bicarbonate ion, can act as an acid by removing one of the H's, another one of the H's. So the reaction looks like this. So you have HCO3-, okay, you react it with water. You're going to end up giving the H plus to the water. So what you're going to have is CO3, okay? As you can see, it used to be -1. If this H comes off, it'll leave another electron behind, so now it'll have a -2 charge. It's the carbonate ion. And the water becomes H3O because it got another H plus, and the charge was 0 plus 1 becomes a +1. Okay? So as a base, it can take an H in this position, as you can see. Okay, so the reaction looks like this. HCO3-, the same substance, can react with water. In this time, it's acting as a base, so it's going to take the H from the water. So now you're going to have H2CO3. Okay, so the charge, you're adding an H plus to this, so +1 - 1 equals 0. And now the water lost an H plus and OH- is left. So as HCO3- acts as a base, it gives off the hydroxide, making the solution basic. Okay? Please do the same thing for sulfuric acid. Pause the video. Okay, so I have HSO4 plus water. It reacts. Here it's acting as an acid, so it gives the H this way. So now we're left with SO4 -2 because the H plus leaves an electron behind, and then now we have the hydronium ion. Okay, and I will tell you about the hydronium ion in a minute and about that structure. Okay, next as a base, we have HSO4- plus H2O. The H goes from the water. Now you have H2SO4 plus OH-. Okay, so water can act as both an acid and a base as well. So water as an acid, water as a base. So what you're going to have to do is you're going to have to react it with another water molecule. Okay. So in the first one, it's acting as an acid, so the H will go to the right. And this water now will take the H. So now you're left with OH- when the H leaves, and this one is the hydronium ion. And then here the H2O gets the H, so now it's H3O plus OH-. Okay? So what happens when acid dissolves in water? So just like here, the H from the HCl, for example, will go to the water and turn into H3O plus, and the Cl- is now by itself. Okay, So what we're building here is something called the hydronium ion. Okay, the hydronium ion has a chemical formula of H3O+, and it happens because the H+, which has no electrons, sits on top or bonds using the lone pairs there. So now the Lewis structure looks like this: H, O, and the 2 electrons used to be here. Now there's an H there, and then H. So they're just lines. And then this is 0 charge, and then the H has a +1 charge, so the hydronium ion has a +1 charge. And in an acidic water solution, you're going to see a lot of hydronium ions floating around, what's causing the solution to be acidic. Okay, so what we have here are, what we're going to talk about next are conjugate acid-base pairs. We have been making conjugate acid-base pairs over here. So let me just show you, first let me define them for you. Conjugate acid pairs are different by 1, only 1 H+, not 2, just 1. The term conjugate comes from the Latin word to conjugare, which means to join together. So they're joined together by 1 H+. That's how they're connected. Reactions between acids and bases always yield their conjugate bases and acids. So look at this equation right here. You have, do you remember what that substance is? That's right, that's acetic acid or vinegar. When you react it with the water, the H leaves, as you can tell by the result here, and it goes to the H2O. The pairs would be this acetic acid and the acetate ion are pairs because what's the difference between them? 1 H+. The other conjugate pair would be H2O and H3O+, because the difference between them is 1 H+. Okay? Now, in a conjugate acid-base pair, one will be the acid and one will be the base. So in this case, whichever has the H+ is the conjugate acid. And the one that's missing the H+ is called the conjugate base. Okay? So in this pair right here, which one is the conjugate acid and which one's the conjugate base? You're right, this is the conjugate acid, and this is the conjugate base. The pairs are all, one is always the acid and one is always the base. Okay? Let's do 16-1, sample exercise. It says, what is the conjugate base of each of the following acids? So I wrote them here. So these are acids, so what they will do is they give away an H+, right? When you give away an H+, this is gone, so now you have ClO4, and it leaves an electron behind, now you have a minus. So the conjugate pairs would be this and this. Those are the conjugate pairs. Okay, in this conjugate pair, this is the acid, and this is the base, conjugate base. Okay, do the same for these 3. Pause the video, please. Okay, good. So arrow, H+, and what you're left with, H, only 1 H and an S and a -1. Okay, the conjugate pairs are this with this. Okay, again, H+. Now, if you remove the positive, it used to be positive already, so now the charge will be 0, okay? pH 3, 0, because 0 plus 1 is a +1. You don't have to write the 0. Okay, again, remove the H+, plus, now you have CO3, the H is gone, the H left another electron behind, now you have a -2. Those are the pairs here, they're different by 1 H, and this is different by 1 H as well. 1 H+. Okay, let's try the next one. What is the conjugate acid of each of the following? So acids, or the following bases. So bases accept H+. So add H+ to all of these, and you will find the conjugate base. Okay, so just put them together. I normally put the H in the front, HCN, add the charge, -1 plus 1 is 0. Okay, pause the video and do the rest. Okay, HSO4 should have a -1. H3O with a +1, the hydronium ion. H+1, There's two H's now and a CO3. And now it's neutral. The conjugate pairs are this and this, this and this, this and this, and this and this. Okay? Exercise 16.2. The hydrogen sulfite, looks like this, is amphiprotic. That means it can either be an acid or a base. Write an equation for the reaction of HSO3, letter A, HSO3, with water, in which the ion acts as an acid. So if this is acting as an acid, what do you think it'll do? Acids give H, so it'll give the H here. So what you'll end up with is HSO3, an H plus left. It used to have a -1, so it leaves another electron behind. Oh, sorry, you should erase it. So the H is gone. So now you used to have a -1, add another electron to it, so you'll have a -2 plus. Now this is the hydronium ion, H3O plus. Okay? You try B. Pause the video. Okay, so HSO3 minus plus water. Okay, it says for B, write an equation for the reaction of HSO3 minus acting with water. It says with water, in which the ion acts as a base. So this is now acting as a base. And bases take H. So now you're going to have H2SO3 because it took the H. Plus 1 minus 1 is 0. And now your water lost one of the H's and left an electron behind. Okay?